Well, good afternoon. I am Fabrizio Zichichi. I would like to thank Commodity Trading for inviting us to present today. I'd like to clearly thank Dave and Dave Hunter, Ora Walpole, Gina, the famous Stallion team, which is clearly very impressive. Now, if I was making a presentation 20 years ago, maybe even 10 years ago, I would say, good afternoon, ladies and gentlemen. However, as a number of you in the audience here are probably the age of my son and my daughter, would say evolve dead. So I'm evolving, and I'm saying good afternoon, sapiens. So we're going to be presenting today's managing waste pollution and driving new circular commodities market. Let me see if I can make this work. Yes, that's the initial title. I don't know how to make this thing go further. Okay, so here is what you can see here in this slide is basically you see what's the result of managing waste. What is the result of waste? This is plastic waste and this is tire waste. And this actually is a result of what could happen if this could be transformed into finished products. So what we're going to do today, we're going to talk to you about basically a theory which is going to give you an idea on what the basics are. We're going to talk to you about reality, and then we're going to talk to you about vision. There is a specific reason why there is a blue color for the theory data aspect of it. There is a specific reason why there is a color in gray for reality, because we are living in a gray situation, apparently. And there is a specific reason why we are seeing vision in green. So I'm going to run by you a study which is basically done by Professor Bradford, professor at the Berkeley University, and Professor Nordhaus, which is an economist at Yale University and a Nobel laureate. So I'm going to show you here the evolution, basically, the evolution of human and the evolution of the world GDP. You can see that a million years ago, it was 125,000 of us living on Earth, which is basically 10,000 people less than what live in Stanford today. In 1 year after the death of Jesus Christ, it was 170 million of us. And then when we got to the 1900, the beginning of 1900 was 1.8 billion. Today, it's 8.5 billion of us. 8.5 billion of us sapiens living here. Just to be clear, we are supposed to continue to evolve all the way to 10 billion by 2050. It's important to remember that of that 8.5 billion, only 46% are basically living in poverty. So that basically makes 3.5 billion people lives in poverty. Now you can see the evolution of the GDP is basically zero. Back a million years ago, and there is a sharp evolution, and you can see basically we have now reached $110 trillion, and by 2050 we are supposed to get to basically 223 trillion. So it's a big increase. Now, one thing though to note is that how does the individuals have gained from this gain in GDP? Individually, where are we? So you can see there is a flat line, complete flat line all the way until 200 years ago. It was $500 per capita. Nothing was happening for thousands of years. Then what happened 200 years ago? Big increase all the way to over $10,000 per capita of GDP. What does it mean? And how is that being driven? Now, what has driven that is basically energy. And how is that energy driven? I mean, I'm going to, again, in the interest of time, I'm not going to start spending a lot of time on this. I'm going to zero in directly in what it is. What has driven us is basically discovery of crude oil and internal combustion engines. These are the two things which have been very relevant. Keep in mind, though, that, again, that $10,000 per capita as an average, you still have 3.8 billion people living on less than $2,000 of per capita GDP, and they all want to live better. So what does it mean, living better? I'm going to shift through this slide in the interest of time. And here is where I'm going to show you the direct correlation between energy. This is from 1900. This is 1900 until to basically to current times. This is basically the direct correlation, which is statistically demonstrated. All of you, I think, knows about statistics. And it's basically, you can see the direct correlation between the growth of GDP and basically the use of energy. The use of energy is expressed in petajoules. Petajoules is 1 million billion joules, which is equivalent to 278 gigawatt per hour. So what's going to happen? I mean, the question is, yeah, we are going to be, you know, we're going to go all the way to 10 billion people. We all want to be, and the people that have less resources want to be richer. What's going to happen to us if we keep doing this, right? What's going to be the result of it? The result of this is that basically we have number of options. Now, clearly, there is one thing which is clear, is that we don't want to be the figure on the right, because that's going to be the result of it. And now, how can we do that? And again, I'm showing you a number of things that are happening from a government point of view, et cetera, but I'm going to be focusing particularly on the title of the presentation, which is using waste as a circular raw material. Now, I am older than a number of you. Some of you have the same age, but I think that I'm going to invite to the podium my colleague, which belongs to the new generation, because we are leaving the new generation with a big burden. So her name is Carlotta Tramuto. She has a management engineering, and she has a master in international business from Holt University. She joined our firm in 2022 as an intern and an analyst. And now she's handling other things, including operation and logistic. But I want to bring her on stage because she's a new generation, and what she's going to be taking this, she's going to talk about what could be the aspect of all of this, and she's particularly going to be concerned clearly about her children, her grandchildren, and everybody that follows. So I'm going to bring her on, and then I'll come back on stage, please.
All right. Hi, everyone. Thank you so much, Fabrizio, for the introduction. I appreciate being here with you today. So let's begin. So let's begin by looking at the projected global trajectory of municipal solid waste. As you can see in the graph, if we fail to take urgent and effective action, global waste generation is expected to see a 78% increase, going from 2.1 billion tons to 3.8 billion of tons. This projection serves as a wake-up call. Now is a crucial time to take action, not just for the environmental stakeholders, but for governments, business, and the commodities sector. This trend directly impacts raw material demand, energy use, and carbon emissions, making waste a central issue in global sustainability strategies. In this chart here, we can see a breakdown of municipal solid waste generation by region. As we can see, high-income regions generate the largest share per capita, as North America, Europe, and Australia and New Zealand. But on the other hand, low and middle-income regions are rapidly catching up because of urbanization and rising consumption. Understanding this regional breakdown helps us identify where crucial economy models like resource recovery and alternative fuel sourcing can have the greatest impact. Let's talk about the gross domestic product and population growth. As you can see from this chart, waste generation is closely linked to both gross domestic product and populational growth. As economy grows and more people join the middle class, consumption, and with it, increase waste as well. If we don't find ways to grow our economies while reducing how much waste we create, we will see an exponential increases in waste. So our challenge and opportunity is building waste-smart systems that turn waste into value or energy in this specific case. Here, we can compare three different scenarios. The first one on the left is waste management as usual, like if we don't make any change, if everything stays as it is right now. The graph in the middle is the waste under control. That means if we start managing our waste better. But the most effective model scenario is the last one, the circular economy, where we reduce, recycle, and reuse as much as possible. In this case, both total waste and waste per person growth will go down. This shows us that the choice we make today, every single day of our life, can lead to a cleaner, more sustainable future. Let's talk about cost. As you can see in this graph, where you can see like a big picture of, again, the three different scenarios, waste management as usual, waste under control, and circular economy, the direct cost of municipal solid waste management is rising drastically if we don't take any action. And it's also a problem for municipalities and taxpayers, because this means high costs for all of us. But for the private sector, it opens doors for innovation to create less waste, spend less money, and recycle more. This last slide shows us again the three different scenarios next to each other. And the overall picture is that the solution is not just a better disposal, but it's redesigning a system around circularity by transforming waste into secondary raw materials, energy, feedstock. We create new chains that reduce cost and support net zero carbon targets. So now Fabrizio will show you one of the possible ways to transform waste into energy. Thank you so much.
So I am back here, and I want to show you, basically, before I finish, I want to finish with what Carlotta was showing. I want to show you basically, I want to show you what it means. The reason why it's still gray is that these are all the products that we are emitting, the chemical of bad origin that we are letting in the ground and everywhere. And I'm going to focus particularly on tires, which is basically a combination of polycyclic aromatic hydrocarbon and 6-ppdq, which is a quinone. So you can see that when we look at it, both plastic waste combined and annual end-of-life tire, you have 430 million tons that can be transformed into energy and 1.7 billion tires that can be transformed into energy. Can we call it raw waste material, raw waste plastic material? Can we call it raw waste tire material? The technology is all about pyrolysis and gasification, so they share that aspect of it. Just to put things in perspective, because I know some of you are familiar with oil, the combination of both is equivalent to around 7 million barrels a day on a volume basis that would be available as raw material to the industry. So now, I told you I was going to focus on tires, so I want to give you a little bit of a picture about tires. Basically, the global tire production annual is 2.2 billion tires. In North America, 337. In order to make tires, you need to produce carbon black. And the global carbon black demand is currently 14 million tons. It's going to go through 60 million tons a year. The global North American carbon black demand is 1.9 million tons. Is 1.7 million tons. It's going to go to 1.9. Now, the most relevant aspect of all of this is that we do produce tires, therefore we produce end-of-life tires. those end-of-life tires in America, globally, is 1.7 billion. In North America is 350 million. So now, what happened to these end-of-life tires? I mean, what happens to it? So now you can see that, yeah, situation doesn't look that bad, because in reality, yeah, you have 1/3 goes to landfill, 1/3 is used as tire-derived fuel. That is emitting CO2 emissions, so that's not particularly good. And 1/3 is recycled. Oh, that's great. I mean, and how do you recycle it? Most of it goes into basically the tire chips, and then used into playgrounds to make surf, and into sport-related activity turf. Now, what's happening now, and a very small portion of it is actually reproduced into carbon black. So now, what is happening? So the problem is that the playground is not supposed to be that good for the individual staying on the playground, particularly the children. So in the city of Westport, since 2018, the use of end-of-life tire chip has been banned. In Europe, the use of end-of-life tire chips into playground and sportsplex has been banned as of October 31. And only 7 days ago, the legislature in Massachusetts has banned the use of end-of-life tire chips to be used in playgrounds. So that means that gray chart I show you doesn't look particularly good. Now, I would like you to pay attention to this state here, state of Mississippi, where we have a total of 3 million end-of-life tires, which are basically being generated. So now I'm gonna very briefly, again, in the interest of time, because I don't know what that is getting. So our dream is to convert all of the tires in the world into basically raw material, which is reprocessed carbon black and sustainable furnace carbon black in the entire year. However, again, it's a dream, it's a vision. Is it realistic? It could happen many decades from now. Now, I'm going to talk to you about a real dream, and which could be vision. It's the USA leading the circular carbon black revolution. Basically, as I showed you earlier, there is the increasing demand in carbon black in the United States, which is, again, is a raw material to make tires, is going to grow by around 190,000 tons a year. And how do we meet it? All of that demand can be met by having 10 new reprocessed carbon black plants in the United States of America, which would meet that demand. And that demand of only the 10 new plants would be equivalent to using 35.4 million end-of-life tires in the region. Remember the number I gave you, the total of the United States is 350 million tons of end-of-life tires. And basically, now that we go to all of the United States, the potential output of using all of the end-of-life tires in the United States would basically mean that combined between reprocessed carbon black and surfaced sustainable furnace carbon black, you would have a 2.45 million ton of production, which basically would make the United States, I showed you the demand is going to 1.96 million ton a year, the United States would be an exporter, actually an exporter of reprocessed and sustainable carbon black, which basically, the result of all of this would make the United States the first fully circular country in the world, turning end-of-life tires into raw, basically raw material to make tires. Now you're going to tell me probably that I'm out of my mind. I'm daydreaming. That doesn't work. Well, guess what? I showed you Mississippi before, right? I showed you Mississippi. Do you remember Mississippi? 3 million tires? Well, right now Mississippi is actually the first circular state in all of the United States. So you see, it's nicely green there. And why is it that? Because our plant, because we have a plant there, Phibro RCB has a plant there, and I'm going to show it to you, as a plant which basically can use all of the end-of-life tires used in produced in the state of Mississippi. Now say, and again, you have a plant? Show me the plant. Here is a plant. So this is a plant These are, if I had more time, I would go through the detail of what the plant is about. Basically, the plant is made of 4 reactors, which are the first one in the picture here, and 2 finishing line. So now, I told you 10 new plants to just meet the demand, right? Well, guess what? We got space, because we have 35 acres of land in Natchez, Mississippi, and the existing plant is where yellow sign is, and these are all the design to build the 5 additional plants, which is the 5 I gave you. And by the way, what would that mean for those plants to basically be built, right? What would that mean? It would basically mean that not only the state of Mississippi would be a fully circular state, then you would have Louisiana, Tennessee, Alabama, and Arkansas becoming fully circular. That's it. They're all circular. In addition, the additional 5 plants would also start contributing, because they would be, in my opinion, would all be built in the South, would contribute to start making Texas, Oklahoma, Georgia, and Florida also circular. So this is where we are. So now, and that would be basically the result. This chart I showed it to you before, and it's, you would see Mississippi would still get the award for bringing the first circular green state. So you can see it's a little greener than the rest of the United States, but all of the rest of the United States would become circular. Now you're going to say, yeah, but how much? I mean, I know Carlotta showed you number before, right? You're talking about $600 billion to deal with the various issues we have regarding dealing with waste, with the waste that we produce, right? So yeah, but how much money are we talking about? Well, it's in the scheme of things, with the $600 billion that you quoted, all of these to make United States of America fully circular would be 11.6 billion. And how do we also, now you are also here as consumers. Now one of the big off-taker for us is tire producers. You know, they produce tires. And what are they giving? They have a mandate to introduce reprocessed carbon black into the system. What are some of the messages I'm getting when I go to meet with them? They are saying, well, the consumer, we have the mandate, but the consumer not asking for sustainable tires, etc. So if, you know, talking about ELTs, right, and end-of-life tire, and also talking about ESG, then if collectively there would be an increased demand from consumers saying, hey, we want to contribute to the circularity of tires, that would also help. And by the way, last but not least, all of this done without a single subsidy received from the government. It's fully circular. So I thank you, we thank you for your time. We have a little bit of time, probably 30 seconds no, we are out of time. I've been a communicator, out of time. So, by the way, this presentation will be sent by PDF, so you can look at it with your leisure. Thank you very much.